recording. We are in our unit evidence for evolution. And we have fully developed the definition of evolution, which is change in traits from generation to generation. It's more than just change over time. Now, this idea is that all species on our planet are related to each other somehow. Therefore, there must be a common ancestor that we all share. And we know that a common ancestor is an early type of organism that two or more other organisms came from. So for instance, you and your cousin descended from your grandparents. Your grandparents are the common ancestor that you guys share. You're all related to each other, okay? Now, after we've defined evolution, we started looking at evidence that supports it. And we started off by looking at fossils. We know fossils are mineralized remains of organisms that have been dead a long time, and we can figure out how long they've been dead, the environment they lived in, and their body structure. But we're actually more interested in looking at the fossil record, where we can link fossils to the law of superposition. So we know that if the fossil's found on the bottom, it's older. A fossil found on top is younger. Now, instead of thinking of each layer as a geological time period, even though it is, we can start thinking about it as different generations. So if we see changes in that fossil, traits are changing from generation to generation, that literally is the definition of evolution. Therefore, the fossil record supports it. We then looked at anatomy, and we know anatomy is studying structures and parts of organisms, but we actually compared anatomy of different animals. So what we did was we looked for similar structures, and when we found those similar structures, we know that those guys are called homologous structures. It could be an organ or a bone that is found in many different animals. And what this is showing us is that they're related somehow. They must share a common ancestor that at one point in time actually gave all the diversified forms of these animals long ago, okay? So again, we defined evolution, then we started looking at evidence for evolution. So fossil record done, comparative anatomy done. The last time we met, you were able to work with a gizmo and see various animals, embryos actually developing. So today, but we didn't get a chance to actually talk about it or get it in our notes. And so that's what we're going to do right now. So I recommend you have your notebook ready. Also, I have questions on Pear Deck, so have your Pear Deck ready. I know I'm asking a lot from you, so please let me know if you need me to slow down at any time, okay? So I have a couple questions. I like to play, right, guess that embryo. I think it's fun. So go ahead and go on the Pear Deck and choose which one you think is the human. So A, B, all the way to H. All right, go ahead and pick one. I see several of you still need to choose. So again, go on the Pear Deck. There's a question there. I'm gonna go grab my water. You answer. All right, I'm missing 3 of you. I need Mike, Jacob, Sydney. Which one do you think? And can you guys lower your cameras, please, so I can see your faces? Gabriel, Sydney, are you even there? Jacob, go ahead and answer on Pear Deck. There we go. Which one do you think is the human? Okay, so let me show you what you guys came up with. All right. Nobody picked A. Nobody picked F. Let me expand this real quick. There we go. It looks like, oh, you guys are changing now. Oh. 3, 2, I'm gonna lock your screens. There we go. Okay, so it looks like we have a winner. G is the one that got the most points. Second place, three-way tie, B, D, and E. Nobody wanted A or C. Somebody changed their mind and made it F. Well, let's see. So let's go to the next slide. We're gonna see a little bit more development going on here. Again, let me change how this is looking. So now you have a little question. Now we see it developed a little bit further. Do you want to change your mind now? Which one is the human? And there's a second part to your question. Which ones are definitely not the human? Okay. All right. I need 4 more of you to respond. Thank you, Sydney. Mike, Luke, Jack, and Gabriel, go ahead and... So there's 2 parts to this question. Which one is the human again? And now which ones are definitely not the human? That's okay, Sydney. All right, volunteers, what do you think? Which one are you guessing is the human? Which ones do you definitely think are not human? Wild guesses. Daniel, what do you think?
I'm still gonna stick with G as the human, and I don't think A and B could be human.
Okay. Somebody else? Mike?
I think either C, E, F, or H are kind of look like humans, and A and B are definitely not humans.
Why do you say A and B are not?
Because they don't have the exact body structure of a human, and like they look more like a amphibian or fish kind of structure.
Gotcha. Anybody else? Okay. The next slide has the answers. Are you ready? Dun, 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 dun. So it might be a little hard to see. This first one is a fish. This is a salamander. This is a tortoise. This is a chicken. This is a pig. This is a cow. This is a rabbit. And this is a human. Human was H. All right. Did you guess correctly? Why or why not? Now, last class, a lot of kids were like, I got it right. How do I answer why I got it right? If it's a wild guess, straight say it was a wild guess, right? Or if there was some things you picked out, then go ahead and put that. All right, so you're back on the Pear Deck. You're answering this question here. I need 4 more of you to respond. There we go. 1 more. Beautiful. All right, Amber, if you could please go back to the Pear Deck. Why or why not? All right, volunteers. I'm more interested in the why or why not. Siddharth, what happened?
I guess drawn because I picked G because it had a similar structure to a human.
Okay, good. Let me hear from at least one more person. Brandon.
I picked incorrectly D because it was more of a wild guess between like six of them. So
What 6?
C and C, D, E, F, G, and H
Okay,
because they look very similar.
okay. Anybody else want to add? Luke, you got to give me the why or why not part. Okay. All right, so you guys hit it on the head, right? If you did get it, it was probably just a wild guess because this is just too hard to actually see. Let me change, hold on, let me do something real quick. I don't want to mess up your pair deck if you're still answering from there. So let me show you. Okay. So if we look at the very first section here, right? Most of you, and I'm reading what you wrote, most of you said they just look way too similar. I got it wrong because you can't tell the difference. Absolutely, right? All of these different organisms here as an embryo, they're not distinguishable from each other. We can't really tell them apart, but they do, and they all share some distinguishable features. Any ideas what all these embryos have in common? If you look at their pictures here, whether it's on Pear Deck or on the Zoom, some volunteers, what are some features that all the embryos actually share? Aditha, give me one.
They all have eyes.
They all have eyes. Yes. Amber.
They have tails.
They all have tails. Good. Now there's a third one that they all share. It's a little bit harder to tell, especially with this picture. Any wild guesses out there? There's a third feature that they share. Oh, Brandon, what do you think?
Gills.
Gills. Okay, very good. So you did your reading. If we have here, you see these little like ridges underneath here. Those are actually gills. So we're going to add these to our notes, right? Embryology and development. At one point, all embryos have a tail, gills, and eyes. You, when you were a developing embryo, had a tail. You had gills. I see some big eyes in my screens. Yeah. You have eyes. That's not a shocker. But your gills as an embryo didn't stay there, right? As you got developed more and more and more as it went along, your gills actually developed into your lungs. Not all animals have lungs, right? They have gills. They kept the gills. Your tail got smaller and smaller and smaller where you don't have a tail, but some animals do have tails. Okay. I actually have a video for you where you're going to be able to watch a human embryo fully develop. And it's kind of, I find that stuff fascinating. So hopefully you enjoy it as well. Okay. Now I want you to think about this. Since all the embryos have those similarities, does that mean that we evolved from each other? A student put in the chat box, I'm assuming they're asking, like, does that mean other animals are going to evolve into humans? So what do you think? In the participants box, you can click yes or no. Does this mean they all evolved from each other? Yes or no? Okay, I have a lot of yeses. Oh, I have some yes nos, like we're not quite sure, right? Well, similar to your Mr. Castillo just responded. That's what that blink was. Okay, so just like comparative anatomy, we see those similarities in the different animals. We're not trying to say that they evolved from each other, but that they are actually related to each other. Okay? And so when it comes to similarities in development, since they have these similar features and they're not distinguishable from each other, this shows that there's some kind of relationship, very similar to those homologous structures with the bones and stuff. Therefore, they must share a common ancestor. Mr. Castillo is going to fix it. Yes. Okay. So I want to clarify, just because the embryos have all these similar features, it doesn't mean they evolved from each other. The salamander didn't evolve into a chicken, and the chicken didn't evolve into a pig, and the pig didn't evolve to the human. So sort of to answer my student's question in the chat, no, it doesn't mean those animals are going to evolve into humans. They might evolve and have different characters from generation to generation, but they've already branched out. They're already differed. Now, I want to point out that when it came to the embryo development, as it develops further and further, we definitely see then they diversify, right? Some animals diversify a lot quicker, for instance, the fish and salamander, than the others. And so it was hard to guess C through H because they do have very similar features. But when they develop a little bit more, it's a lot more obvious how they differentiate later on. Okay. So let's go to Imagination Land. And I'm kind of creepy with this Imagination Land. I hope you're okay with creepy. Okay. So Imagination Land, you and I are shopping at the black market. Okay. And we're just strolling along, having a good time. You really want to buy a puppy. So you're like, oh, I hope I can find a puppy. I really want a puppy. And all of a sudden, this shady guy comes around. You want a puppy? And he opens up his suitcase. I have a puppy. It's just an embryo, though. Just, take it, Imagination Land. You have like an embryo growing machine in the closet. No big deal. Everybody does. Imagination Land. And they're like, here, you want an embryo? And you're like, oh, yeah, are these puppies? He says, yeah, they're puppies. Oh, okay. Yes or no? Is that a good idea just to pick out the puppy embryo? Yes or no? You can put in the chat box. You can click participation. I need you to, there we go. Oh, somebody put scam artist. Share with me why wouldn't that be a good idea to purchase a puppy embryo? Why would that not be the wisest choice for you to do this here? Volunteers actually talk to me. Amber, why would that not probably be a good choice?
Because a lot of embryos look similar, so it's hard to tell.
Okay, Jacob.
The embryo needs to be like in the correct place to actually like to grow right.
Okay, but it's imagination land. You have like a super embryo 3000 that's going to grow your embryo just right. So they're all similar, right? So what's a risk you run? Well, what the price is. See if you have much. Elise, what's the risk?
It might not be a puppy, it might be another animal.
How sad, right? You get it home, you put it in your embryo 3000 and it's growing, developing, and then all of a sudden you see it's a salamander. Oh man, you got taken. Dang it, right? Oh, darn that guy. So, right, you can't tell when it's an embryo because they look so similar together. The similarities are indifferentiated. You can't tell the difference at this stage. The very early stages, they all have those eyes, gills, and tails. It's really hard to tell. Okay? Questions on any of this? All right. I do have a video that I want you to see about the developing embryos, but we will do that after our first break. Okay, so let's go ahead. I'll leave it on that slide on Pear Deck, but let's go ahead and do our 3 minutes and then we'll come back. Get up, stretch. All right, we have a video and let's enjoy.
This 3-week-old pig embryo already shows signs of a growing tail. In 2 more weeks, the tail has developed further. In its early stages, a chick embryo also shows promise of a tail. But just a few days later, the tail is gone. At 4 weeks, a human embryo also shows indications of a tail, seen at the right. Traces of a tail occur in each embryo, mementos of a heritage we all share. At 6 weeks, though, the tail is just a small vestige at the spine's end. And 1 week later, it has dwindled to a bud, seen just beneath the legs. Animals that lack tails share a common ancestry with those that have them. Our shared ancient beginnings on land and in water link us together despite our ultimate differences. Human limbs begin as buds, seen as early as 5 weeks in this embryo. At this stage, an arm bud, seen here, appears very similar to this leg bud. By 10 days, the limb buds are shaped like tiny paddles, and distinctions between arm and leg buds are visible. The distinctions can seem slight. A human arm at this stage still looks like a pig's embryonic front leg. Bird embryos at this stage show extraordinary similarities to those of humans. The left bud, looking so much like a human arm, will ultimately develop into a wing. Each species starts with a shared beginning, but takes a distinct course, acquiring distinguishing traits of its own. The embryo of a chicken follows its own path. Human-like at first, the pig embryo soon takes on its own distinctive form with snout and tail. The fish embryo soon differs profoundly from a human, reflecting an evolutionary course that diverged on its own long, long ago. Sharing ancient beginnings with these others, the human embryo.
All right, so hopefully you enjoyed that video. I know I find it fascinating how embryos develop and whatnot. So let's tie this all together. Let me change how I'm sharing again. And let's go here. So again, we see that embryos all have very similar traits. They have eyes, gills, tail. And it's almost impossible to distinguish one from another in the very beginning. Now, as you saw in the video, as they develop further and further, some diversify very quickly. Others don't diversify from humans until later on in their development, which also indicates a stronger relationship with us there, okay? So showing these, comparing these commonalities is showing us that they have there's a relationship between these animals. Therefore, they must share a common ancestor, okay? Any questions on embryological development? All right, so that's our third type of evidence. We're going to get into DNA comparisons next, okay? So, I wonder why it didn't do that. I'm looking at the next slide and it didn't fix what I wanted you to do. So, do you see the question? Because I don't see it on the slide. Okay, so the question is, what do you already know about DNA? So now you have to toggle back to the Pear Deck presentation and go ahead and let me know. What do you already know about DNA? I'll put that in the chat box. I don't know why the slide doesn't say that. So please go back to the Pear Deck. I'm missing 7 of you. And let me check my slides and wonder why it's not there. It's there, but it's not here. So weird. Sorry if I messed you up. I'm sorry. Go ahead. What do you already know about DNA? So Daniel Kim and Luke, go ahead and on Pear Deck. What do you already know about DNA? All right, volunteers. What do you already know? Let me lower the hands and then you can re-raise your hand. I'm sorry, I just lowered it for you. Samya, what do you already know?
DNA is anything that helps like recognize someone or something, like fingerprints, structures, anything like that.
Okay, Brandon.
They always differ from their parents or the originating organism.
Okay, Aditha.
I know that the cells in a person's body has something to do with DNA.
Okay, good. Anybody else? Everybody's so quiet. So good. And in fact, our next unit is on genetics. You're going to learn a lot about DNA. So I'm not going to go into it very deep right now. But DNA actually stands for deoxyribonucleic acid. Whew, that's a handful, right? And all species have their own unique DNA, and it's passed on. I'm reading what you guys are writing in the Pear Deck. And a lot of you are saying it's from your, carries on from your parents, right? It's passed on from generation to generation. So that's what's called heritable material. Now, the species that share more similarities in their DNA are more closely related, okay? So this is what we're going to do. You're gonna actually work in pairs, and I'm gonna leave it on this slide for right now. I'm gonna go to my other thing. So you're actually going to work in pairs. Let me scoot forward. Yep, there's that slide. Okay, you're going to work in pairs. I'm going to send you to breakout rooms. You're not going to be there for very long. You're going to be there for 10 minutes because what you're going to do is you're going to actually, if you're done with the Pear Deck, go ahead and click on the Zoom screen so you can see what I'm talking about. You're going to look at 8 different animals. We have a cow, a fly, a rooster, a mouse, a cat, banana, a chimpanzee, and a human being. Now, I already numbered humans number 1. And what you're going to do is you're going to actually draw on this slide when I let you, not yet. And you're going to number the animals from closest, who shares the most DNA with humans to who shares the least amount of DNA. So number 2, who do you think is closest to humans all the way to number 8? Who's the furthest? After you number them, you're going to answer a quick question. And then you're going to actually get a link to this article that tells you how much DNA is shared between humans and these other animals, okay? So you're gonna work together with your partner. When you finish, you're gonna answer these questions. When you finish, you're going to come back to the main room, okay? And then we'll take our last break and then we'll talk about what you found out. All right. So what I'm going to do now is change the Pear Deck to student-led, student-paced, and then I'm going to send you to work with a pair in a breakout room. Any questions before I kick you out? Okay, there's 25 of us today, so we're going to have one room of 3, okay? 24, there we go. All right, let me scan real quick. I need to move me. Here we go. All right. Talk to each other. Please have your mic on and then work together on these questions. All right, you guys, 10 minutes. It's 10:25. I'm going to bring you back at 10:35. All right, here we go. Have fun. And what I would like to do in those 9 minutes is discuss what you found out about DNA. So you have options of volunteers. You can choose any of these questions. Which ones did you get correct? Which ones did you not get correct? Did anything shock you? If so, which ones? And again, it's days like these that I miss you in the room because I can usually hear you go, what? No way, that's impossible. You guys are like freaking out in class. So we can freak out online. Let's do that. Okay. So Siddharth.
I got the monkey and banana correct.
Okay, thank you. Samya.
I got chimpanzee, banana, fly, and cow correct, and I got cat, mouse, and chicken wrong, and I'm shocked by the cat.
Why? Why does the cat shock you?
Well, I thought it would be like further away from a similar DNA than us. So
Okay. Jack.
I only got chimpanzee and banana correct, and I got everything else wrong. But and then one thing I was shocked by was the cow. I was shocked by it because, as to me, it looks like a much different bone structure. It uses kind of four limbs and everything, so that really shocked me.
All right. Thank you. Brandon.
I got the chimpanzee, the banana, the cow, and the fruit fly correct. I didn't get the rest correct, obviously, and the one that shocked me was the banana because it had a lot more DNA related to humans than I thought.
Okay, good. I'm glad you brought up the banana. Usually people are like 60%. Is that right? The banana was 60%. That's a lot of DNA, right? Okay, good. Daniel.
I think I got one right. That was the one was given to me, which was humans, and which one did not get correct was the rest of them. And then the thing that shocked me most was that banana has the same percent of DNA shared with us as chicken.
Okay. I'm not sure if it was this class, but there was one class that there was a student stuck on the pumpkin pie thing. Remember that video we watched like the first day? And it was talking about how the pumpkin pie is related to you. Well, this is how, right? And 60% of your DNA you share with fruits and vegetables. There's a lot of the DNA that they have that you also have that give you some similar characteristics. But obviously, it doesn't sound, it blows your brain to think that they share 60%. But did anybody read who you shared the even more DNA than the chimpanzee? Did anybody remember reading that in the article? Or did you just skim right to the pictures? Hmm? Okay, in the article, it said you actually share 99.9% of DNA with other humans. So if I look at my screen right now, I see all these beautiful faces. You share 99.9% of the DNA with them. Okay, that's okay, Jamin. There's only and we have the wide, vast variety that we see in our world from human to human is only due to 0.1% difference in our DNA. So to me, that kind of blows my mind to think that all you need is a 0.1% difference, and we have different sizes, shapes, colors, hair, nails, everything can be so drastically different from each other, and it's only due to a 0.1% difference in our DNA. Pretty fascinating. Okay, so now I'm going to challenge you one step further. How do you think comparing DNA supports evolution? I'm going to give you a moment to think about it. And then I'm going to ask for some volunteers. How do you think looking at the DNA of different species supports this theory of evolution? All right, any volunteers? Let me lead you a little bit. Kind of like the embryo thing, right? Are we trying to say that we all evolved from each other? You can click yes or no in the participants box. You can put yes or no in the chat. Are we trying to say that we evolved from each other? I have one person. Where's everybody else? Wake up. Yes or no? Stay with me. Need to wrap this up. Did we evolve from each other? This is that controversial topic, right? All right. I have very few yeses. I have a lot of no's. That's not what this is telling us, right? Comparing DNA simply tells us that we are related to each other. So, the more DNA you have in common with another species, the closer of a relative they are. Not that you evolved from them, okay? This is a poor choice of pictures because they actually evolved from each other. But not that you evolved from each other. I'm not trying to say that once upon a time you were a banana. Okay, that's not what I'm trying to say. What I'm trying to say is that we are related to bananas, believe it or not. If we go far enough back in history, there's going to be a common ancestor, a far distant relative that we share with the banana. Now, at one point, we diverged in diversity, just like we saw those embryos developing, so did our DNA. Our DNA changed first, and that made our traits change, and then our features change, etc. Again, our next unit is going to be on genetics, so you're going to be able to see the link here, how DNA plays a vital role in your actual characteristics, okay? So, let me make it very clear. We are not saying that you evolved from any of these animals. No. What we are saying is due to the fact that you have so much shared DNA with them that you are related to them somehow. There is a distant common ancestor that you share. And the more DNA you share, the closer that relative is. Okay? All right, you guys. If you don't have any questions, I want to remind you to make sure you get that STEMscopedia reading done. Update your notebooks. This is the last day of notes. This is it. Then next time I see you, we're going to actually review because your final exam is going to be next week. Okay? All right. If you don't have any questions, I hope you have a great day, and I'll see you on Friday. Have a good rest of the week.
Bye. Have a great week.